Hello friends, subscribers and new viewers of this channel, and welcome to FreeCAD tutorials. In this tutorial, we explain what are and how to use constraints in 2D sketches. So what are the constraints? Namely, after you open FreeCAD, you will see this set of buttons or this set of icons. These set of buttons are used to define the constraints, and they are very important. In order to properly explain what are the constraints, we need to define several things. First of all, we need to define objects. Objects are points, lines, circles, rectangles, etc. Then, geometrical properties of objects are length, radius, angles, etc. Geometrical relationships between objects are tangent, normal, some predefined angle, symmetry, etc. Finally, we can define constraints. Constraints are user-specified geometrical properties of objects and geometrical relationships between objects, and this is very important. Constraints are used to precisely define and constrain the 2D geometry. In this tutorial, we explain how to correctly use constraints in 2D sketches. Compared to some other CAD software or programs, in order to properly design a 2D sketch, we need to properly set constraints. If you do not set the constraints properly and leave some degrees of freedom undefined, and we will define and explain degrees of freedom later on, the geometry might change after you perform some operations. So keep in mind that. Always constrain the 2D sketch. Okay, let's start with explanations. First of all, let's open FreeCAD. In this tutorial, I assume that you have very little or almost no knowledge about FreeCAD, and consequently I will spend additional time explaining some basic things. Once you open FreeCAD, you can create a new sketch by clicking here, and then once we are over here, let's click over here, click on Part Design, let's click on Create Body, then Create Sketch, and let's select our plane. I will select XY plane. Over here, to ease our modeling, let's click here to turn on the grid. Then over here, let's adjust the grid spacing. Let's keep the grid spacing to 5. And over here, click on this drop-down menu and make sure that Snap to Grid is selected. First of all, I will explain constrain vertically and constrain horizontally. For that purpose, click over here to create an arbitrary line. For example, I will click here and I will click here. Now what you see over here is an arbitrary line, and if you press escape, you will exit the line mode. Let's say that we want to make this line to be vertical. To do that, simply click on the line and click over here on constrain vertically, and voila, here it is. Now the line is vertical. Let's repeat this process for the horizontal constraint. So let's construct a line, press escape, then select the line and click here to constrain the line to be horizontal. Perfect. Next, if you're creating an object or some sketch, you would often need to constrain 2 points such that they are coincident. That is, that they are on top of each other. So let's learn how to do that. Select this point over here, then select this point over here, then click here and magic happens. Now these 2 points are coincident. Let's explain what's written over here. Now, on top of the line over here, if you click, you will see that over here this constraint is being selected. And this means that over here you can see all the constraints we have. First of all, we have this constraint, and you will see that this line became green. This is the vertical constraint. Then we have the horizontal constraint, and over here we have the coincident constraint. Good. Next, we explain how to constrain two lines to be perpendicular and parallel. To do that, let's first construct two lines. Here's the first line, and let's construct the second one. Here's the second one, and press escape. Then select this line, and then click over here to constrain parallel. And now you will see over here that this line is parallel to this line. You can click over here, and however you move this line, you will see that it will stay parallel with this line over here. And over here you will see the corresponding constraint. Next, let's learn how to do perpendicular. To create a perpendicular or normal constraint, let's first construct the first line, the second line, press escape, select the first line, select the second line, and click here to have the perpendicular constraint. And now you can see that this line is perpendicular to this line. And however you move this line, or even if you try to move any of the points over here, you'll see that the lines will stay perpendicular, which is very, very important. Next, we explain how to make sure that the lengths of two lines are equal. The same applies to other geometrical shapes. Let's construct two lines. Here's the first line, here's the second line, and we would like to make sure that the lengths of these two lines are equal. To do that, select the second and the first line and click over here. And now the lengths of these lines are equal. To see the lengths of these two lines, simply click here, then click over here, select this line, and you will see the length. It's 6.16, and if you click here, you will see that it's 6.16. Now, what I did over here by clicking over here, I went from driving to the reference constraint. And currently, I'm in the reference constraint, so I turn off these constraints. Okay, so let me go back, click again here, so that I'm in the normal constraint mode. Next, we explain how to use the symmetry constraint. The symmetry constraint is very useful if you want to make sure that two lines or 2 points are symmetrical with respect to another line. Let's explain how to use the symmetry constraint. First of all, let's construct a reference line. So let's draw a line from here to here, and then over here I will construct another line. Here's the first line, and I will construct the third line. For example, the line over here. Then, what I will do over here, I'm going to constrain the distance from this point to this point. So I will click this point, I will select this point, and then over here, I will click on constraint distance, and I will put the distance of 25. Okay. Let's now do the same thing for these 2 points. So I will click here, I will click here, then again on constraint distance, and let's put 35 over here. Good. Now, what I would like to do is to make sure that the distance from this point to this line is the same as the distance from this point to this line. To do that, we will simply use the symmetry constraint. So select this point, and select this line, and click here, and magic happens. Now the distance from here to here is the same as the distance from here to here. And so let's make sure that this is actually the case. To double check this, click over here, then click here, and measure the distance. Or actually, I cannot do it exactly like this. I need to correct myself. I need to click over here. So let's repeat this. Click here, and click here, and then click here, and you can see that the distance is 12.5. Then let's make sure that this distance from here to here is the same. Click here, and click here, and you'll see 12.5. Next, I will explain how to constrain the length and the distance. For that purpose, I'm starting from scratch. That is, I erased all the previous lines and points. Furthermore, make sure that this option is red. By clicking over here, you will make sure that everything is red over here. Let's start. Let's construct a simple rectangle. Click here and click on rectangle and construct a simple rectangle. Press escape. Next, I would like to make sure that the distance from this point to this point is constant. There are several ways to fix this distance. Let's explain the first approach. Simply click here, then click on the other point, and then over here you have this option, constrain horizontal distance. By clicking here, you will be able to set the length. So let's set the length 35, and here it is. Now, let's explain the second approach. Click on this constraint and you will see that over here it will be selected, and press delete to delete it. The second approach is to simply select the line and then click over here and set the constraint 40. Here it is. Let's do the same for the vertical distance. That is, I would like to constrain that the distance from this point to this point is fixed. To do that, again, we have several options. The first option is to click here, and then click on the constrain vertical distance, and let's specify 25. Here it is. Perfect. And of course, the second option would be to simply select the line and click here. Now we know how to constrain the length or the distance between 2 points. Next, I would like to center this rectangle at 0, 0. There are several ways to do that. Let's explain the first approach. The first approach is to use the symmetry. Consequently, select this point, select this line, and simply click over here on constrain symmetrical. And you will see that currently we have centered this rectangle with respect to the vertical line. Let's do the same thing with respect to the horizontal line. So click here, then click over here, and then click on constraint symmetrical, and here it is. Now our rectangle is fully centered. Perfect. Next, we explain how to constrain a radius of a circle and how to make sure that line is tangent to a circle. So let's erase this rectangle and let's construct a circle. Click over here and click here and specify an arbitrary radius. Next, what I would like to do is to make sure that this radius is user-defined. Consequently, press escape and click over here on the circle, and then click over here to constrain the diameter. So let's specify the diameter to be 30. Next, let's explain how to construct a line that's tangent to this circle. First of all, let's construct a line. Here it is. Now, what I would like to do is to make sure that this line, or better to say that this line sits on some other direction or a line that's tangent to this circle. To do that, click on the line, click on the circle, and over here you have constraint tangent. And here it is. Now the line is tangent to this circle. And whatever I do, for example, if I move the line, if I change the direction, you will see that always this line will stay tangent to this circle. This is a very powerful method. Next, we explain how to constrain angles between two lines. First of all, let's erase everything over here and let's construct two lines. Here is the first line, and let's construct the second line. Here it is. Let's constrain the angle between these two lines. First of all, select the first line, select the second one, and then click over here on the constrained angle, and you will see the angle over here appears. And let's set this angle to be 35. And here it is. Now, what happens over here? These two lines intersect somewhere over here. And of course, you don't see the actual angle. The angle is shown over here. So let's expand these two lines, and however you expand any two of them, you will see that the angle over here always remains constant. And this is very, very important technique. Good. Next, we explain how to completely define the degrees of freedom. That is, we explain how to completely constrain our sketch and all the degrees of freedom. For that purpose, let's erase these two lines by selecting them and pressing Escape. Over here, you will see that we don't have any constraint anymore. This is because we don't have any shape over here. Next, let's construct a simple rectangle. But before doing that, make sure that the grid is off. Then click here and construct a rectangle. Here it is. Then press Escape. First of all, observe how many constraints we have. We have 1, 2, 3, 4, 5, 6, 7, and 8. These 8 constraints are used to define the rectangle shape. That is, these are the constraints between the points and lines, and lines and lines that define this geometrical shape. However, over here we can see that this sketch is under constraint. We can see that we have additional 4 degrees of freedom that we need to fix. Why is that? Well, let's analyze this rectangle. Over here, I can change the height or the length of this line by simply clicking here and by moving this line. And also, if I move left and right, I can see that my rectangle can change the position. On the other hand, I can select this line, and if I move it left or right, the length of this line will change, and my rectangle can move up and down. Consequently, its position and the lengths and the heights are not fixed. This means that we have additional 4 degrees of freedom that we need to specify. Let's look at this problem from another point of view. That is, from the mathematical point of view. 1 degree of freedom that defines the shape of this rectangle is the length of this line, and we can change it. Then another degree of freedom that defines the shape of this rectangle is the length of this line, and this is the 2nd degree of freedom. That is, 1st degree of freedom is the length of this line, the 2nd degree of freedom is the length of this line. However, in addition to these two lengths, we can also vary the position of this rectangle. Namely, we need to specify the coordinates and to fix the coordinates of any point on our rectangle. For example, this point over here can move right or can move up. And we need to fix its coordinates. And its coordinates are actual 2 additional degrees of freedom. That is, the degrees of freedom are length of this line, length of this line, and the coordinates, that is x and y coordinates, of any point on the rectangle. Observe here one very important thing. The degrees of freedom are not unique. Over here I define degrees of freedom as this length, and the coordinates of this point. However, I don't need to do that. I can simply say 1 degree of freedom, which is actually 2 degrees of freedom, is the distance from this line, from this point to this point. And I can fix that distance, right? In addition to this degree of freedom, which is the the distance from this point to this point, I can define another degree of freedom, which is the distance from this point to this point. And this makes in total 2 degrees of freedom. In addition to this, I need to specify the coordinates of any point on my rectangle, for example, the coordinates of this point, and this will bring an additional 2 degrees of freedom, which makes in total 4 degrees of freedom. Next, let's explain how to completely constrain or how to completely fix all 4 degrees of freedom. Let's start by constraining this length. So click on this point and click on this point, and then over here click on constrain horizontal distance, and let's specify this to be 150. And look what happened. Now we have 3 degrees of freedom that we need to fix. Let's now repeat the same thing by clicking here, and now clicking on this constrained vertical distance, and let's specify 110 over here, and now we have 110 and 150, and we have only 2 degrees of freedom that we need to specify. So what are these 2 degrees of freedom? For example, we can define the coordinates of this point with respect to this point. That is, we can fix the coordinates or the position of this point with respect to this point. So let's do that. First click here, then click here, then click on horizontal distance, and let's set the X position to be 80. And let's repeat this for the vertical distance. So if I click here, and if I click here, I can specify the vertical distance to be 70. And now voila, fully constrained, green. Everything is green right now. Green means that we have fully constrained our shape. Next, let's learn how to constrain circles. Click over here and construct a circle. And let's see what do we have now. We have 3 degrees of freedom. Why 3 degrees of freedom? First of all, we can change the radius of a circle, and then we can change the coordinates of the center point of the circle. Let's press escape to get out of the circle option. So let's first constrain the radius. Click here, and let's set the radius or the diameter to be 60. Now we have only 2 degrees of freedom. To fix the additional 2 degrees of freedom, we need to specify the coordinates of this point. So click here, and let's set the vertical distance to be 100. Then click here, and let's specify the horizontal distance to be 180. And here it is, fully constrained. This looks perfect. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.